Okay, so after our discussion of the scientific method, uh, well, again, this is part two of the second lecture. We're talking about, or we will talk about atomic theory. The atomic theory, as proposed by John Dalton around the early 18th century. The first idea is that all matter consists of atoms. All matter. Matter that we interact with, physical matter, matter that basically consists of all of the states that we talked about, solids, liquids, and gases. The second part of his theory is that elements are composed of billions. Elements, talk about elements in the periodic table, are composed of billions. That is 10 to the 10 to the ninth billions of only one kind of atom. So we're talking about a single element consists of billions of a single type of atom. Okay, for instance, the element of oxygen. Alright, oxygen we think of as a gas. This gas is an element, and that element consists of billions of atoms that are interact with one another to give us the characteristics of oxygen. Iron. Okay, we're quite familiar with iron, the elemental iron. Notice I don't put a charge. There's no charge on these. All the elements in the periodic table are neutral. But again, iron consists of billions of atoms that give iron its characteristics, and these atoms are different from those of oxygen. And the third part of this theory is that compounds are matter made up of two or more different R-E-N, you know how to spell different atoms and these different atoms are chemically linked. Okay, so we say they're made up of different atoms, but they're chemically linked or combined. We'll talk about how this combination or linking of atoms occurs. And they're linked in fixed proportions. Okay, fixed proportions. This has to do with a law of multiple proportions. For instance, if for a very simple example is water. Water consists of hydrogen and an oxygen and another hydrogen. Okay, there are 2 hydrogens and 1 oxygen element in water. Alright, and those atoms of hydrogen and oxygen combine in this ratio of 2 to 1. If we change that proportion and we say, alright, we want to have 4, or I should say we should have 4 elements, 2 of which are hydrogen, and 2 of which are oxygen. Alright, that proportion, 2 to 2, or 1 to 1, is different from the 2 to 1. 2 to 1. Okay, we can say 2 to 2 or 1 to 1 when you express proportions. This element, or this compound, remember, 2 or more different atoms, and this compound are completely different. One you know is water. Do you know what this is? The Lewis structure is not exactly correct, but this is peroxide, and that's distinctly different from water, and the difference is simply in the proportions. Alright, so let's move on to understand how atoms are arranged, and then we'll talk about some of those properties that make up an atom, those subatomic elements, or subatomic particles, not elements, that make up an atom. So quickly, we're all familiar with what an atom looks like in caricature. You've seen it represented like this, possibly. This is more of a symbol from my generation. Okay? And so in this illustration, this was representative of the atomic age, or radioactivity, or danger, in a sense. This is essentially from the 60s propaganda. Well, the actual arrangement of an atom was developed, or was proposed by Niels Bohr, and his model consisted of an electron cloud. Okay, we'll put an electron in there. And in the center we had a nucleus. So this is a nucleus. And this is our first subatomic particle, the electron. And we'll talk more about the electron later on, but we know from experience that electrons are negative. And in actuality, their size relative to the nucleus is very small. This is certainly not representative of it. And as a matter of fact, the size of the nucleus relative to this cloud is much, much smaller than this. But to give you an idea, we have the electron and the nucleus, and what is in the nucleus? Inside the nucleus, we have 2 subatomic particles, usually, we have protons, and we have neutrons. All right, and from experience, you probably remember that protons are positively charged, and there's no charge on the neutron. I wouldn't say that they have a zero charge, because that's a charge. They actually have no charge. But in this example, this nucleus with one electron has only one proton, but no neutrons. Alright, and this element, or this atomic structure of the element, is representative of hydrogen. Because hydrogen has one proton, one electron. The proton being positive, the electron being negative, gives the atom zero charge, and there are no neutrons in there contributing to the atomic mass. So the atomic mass of hydrogen is actually 1. It's a little larger than 1, but all of the mass is considered to come from the proton, because the electrons are the mass is so small relative to the proton that it is not even considered. So this is the atomic mass of hydrogen. Okay, we'll move on in our next lecture to subatomic particles, the characteristics of these particles, and the periodic table. We're going to learn some things from the periodic table. So we're going to begin by talking about the elements and what the periodic table means. Thanks for listening. This is Dr. Carroll, South Central Louisiana Technical College.